Welcome back. The objective of this video is to multiply and divide numbers in polar or trig form. And the second thing we're going to do is we're going to introduce DeMoivre's theorem. So let's take a look at our trig or polar form of numbers. So we have two numbers, z1 and z2, that are both in trig or polar form. If we're going to multiply these together or find the product, we're going to multiply the moduli and we're going to add the arguments. Or we're going to multiply the r value and add theta. So this is a little bit like our laws of exponents and logarithms, where if we do multiplication, we're going to be adding. And in division, if we do division, we're going to be subtracting. So keep in mind, though, here when we multiply, we're going to multiply the r's, but add the angles. And when we divide, we're going to divide the r's, so r1 divided by r2, and this is a case where order is going to matter. And then we're going to subtract the angles, subtract angle 2 from angle 1. Again, order is going to matter here, so we have to be careful about that. Okay, so we have to pay attention, especially for division, what's z1 and what's z2, so then we have the correct order. So pay a little bit closer to the quotient or division than the product. So we've got our formulas here. Remember, if we're multiplying the r's and adding the thetas. So example 16 says multiply and leave your answer in polar form. So we're going to multiply 2 cosine of pi over 3 plus I sine of pi over 3. And we're going to multiply that by 3 cosine of pi over 4 plus I sine of pi over 4. So multiplying, we're going to do z1 times z2. So I'm going to just show it this way. We're going to do z1 times z2 equals 2 times 3. We're going to multiply our r's, and then we're going to add our thetas. We're going to need a common denominator to add our thetas, but I'll just show we're going to do the cosine of pi over 3 plus pi over 4, and then plus I sine of pi over 3 plus pi over 4. So our common denominator here is 12, so we have 6, and then we're going to have the cosine of 4 pi over 12 plus 3 pi over 12 plus I sine of 4 pi over 12 plus 3 pi over 12. And we all know that is 7 pi over 12. So we get 6 cosine of 7 pi over 12 plus I sine of 7 pi over 12. I should be pretty more careful with my parentheses and brackets to avoid any confusion. So I should keep that as parentheses there. And that's really our final answer. I don't know what this is, but I could put this into my calculator, make sure I'm in radian mode, and if I did that, I would get an ordered pair of negative 1.553 plus 5.800i. Now this form would not be polar form anymore. This would be standard form or rectangular form. So that would be rectangular form or standard form. So where I put this in my calculator and got that particular answer. And those answers are to 3 decimal places. That's the AP format. So you're always safe going to three decimal places. So our trig form, and then using our calculator to find the rectangular form. Let's do example 17. We're going to divide our numerator. I'm going to call that Z1, and the denominator is Z2. So we want Z1 divided by Z2, which will simplify to 2 over 6. So we'll have 1 over 3, or 1/3. The cosine, now we're going to subtract the bottom from the top. So we have the cosine of 9 pi over 16 minus 6 pi over 16 plus I sine of 9 pi over 16 minus 6 pi over 16. So all I did is get a common denominator so I could subtract these, and see I'm subtracting the bottom angle from the top, and we get 1/3 cosine 9 sixes at 3 pi over 16 plus I sine 3 pi over 16. And that would be our final answer in polar or trig form. There's nothing more we can do here. That's the format we want. That's our angle mode. If we wanted rectangular form, we'd have to do our calculator. So if we want rectangular form, we'd have to put it in the calculator, and we would get Z1 over Z2 equals 0.277 plus 0.185 I. So this is our rectangular form, and we got that by putting that into our calculator, by putting the polar form using radian mode into our calculator. And finally, we have DeMoivre's theorem. If z equals r cosine of theta plus I sine of theta is a complex number and n is a positive integer, then z to the n equals r cosine of theta plus I sine of theta to the n. And z to the n is equal to r raised to the n. So we take that exponent and we raise it to r, but we also take that exponent and multiply it by theta. Okay, that's what DeMoivre's theorem says. So an example like 18 here. So z equals 2 cosine of pi over 12 plus I sine pi over 10 raised to the 4th. Well, that will then equal z equals 2 raised to the 4th, because I can take that exponent and raise it to the 4th power. And then that 4 becomes a coefficient or on pi over 12. So 2 to the 4th times the cosine of 4 pi over 12 plus I sine 4 pi over 12. So now z is equal to 2 to the 4th is 16, and the cosine of 4 pi over 12, that's the same as the cosine of pi over 3, just simplifying that fraction, plus I sine of pi over 3. In our previous samples today, we went to the calculator, but now this is on the unit circle. So I can just go to my unit circle. I can go to pi over 3. Why does it look like I have pi over 13 here for and the sign? And pi over 3 is in the first quadrant in my unit circle, and my order of pair is 1/2 square root of 3 over 2. So simplifying, we get z equals 16. Cosine of pi over 3 is 1/2 plus I. The sine of pi over 3 is the square root of 3 over 2. I can distribute my 16, and I get 8 plus 8 square root of 3, or 8i square root of 3. and I don't need that bracket any longer. And now I'm in my complex form or rectangular form, and I've solved for z using DeMoivre's theorem. So we'll get some more practice with multiplying and dividing trig form of complex numbers, and we'll also get some practice with DeMoivre's theorem when I see you in class.